Those are online. Are you able to see my screen?
Yes, sir.
Is it training? Is it raining? No idea. Check and come. So this class will do some problems which are based on previous year questions. Okay. Yeah. Listen. So the first question that we are going to see is So first question that we are going to see is there is a 500 microcoulomb charge which is placed at the center of a square of side 10 centimeter. Find the work done in moving a charge 10 microcoulomb between two diagonally opposite points on the square. Okay. So what is that you have? You have a square of side. You have a square of side 10 centimeter. And there is a charge which is placed at the center of value 500 microcoulomb. Okay. So there is a point A here, B, C, and D. Our job is to find what is the amount of work done to move a charge of 10 microcoulomb. There is another charge of 10 microcoulomb which is to be moved from the point A to point C. So how much is going to be the work done? So if you see, the concept is very simple. Whenever you need to move a charge from one point to another, work done is the amount of potential energy that is going to get stored. So U will be equal to Q into the charge that you're trying to move into the potential difference between the points across which you're trying to move the charge. I can either take it as VAC or VBD also, it's my wish. So in this question, what you need to understand is the first charge 500 microcoulomb is acting like a source charge. So due to the source charge, there will be a potential that is developed at the points A and C. Am I right? So due to the source charge, there is a potential developed at point A and there is a potential developed at point C. Right? So if I take this distance to be R, then can I say this distance is also R because they're symmetric with respect to that point? Now, what is going to be the potential of point A? It is going to be K into capital Q divided by R, where capital Q is what? 500 microcoulomb divided by this distance. Similarly, what is the potential at point C? It is also going to be K into capital Q divided by the same distance R. So what is the point we are able to conclude from this? The potential at point A is exactly equal to the potential at point C. So what is going to be the potential difference between them? 0. So can I say VAC, which is basically VA minus VC, this is 0. So if I take this and substitute it here, what do I get the work done as? So there is no amount of work that you're going to do in this scenario. So work done is going to be 0. And what will be the reason you're going to write in the exam? You'll say that the point A and C are at the same potential, hence the potential difference is 0. Is it clear? So make a note of this. So don't write the question, okay? I'll be sharing this sheet after the class. So don't write the question, only write down the solution and put the correct question number because they are not in order. This first one. Shall I proceed? Yeah.
Yes, sir.
So here comes the next question. A point charge Q is placed at point O as shown in the figure, right? If the potential difference VA minus VB, is the potential difference VA minus VB positive, negative, or zero if Q is positive and if Q is negative? Okay. So what we need to find is VA minus VB, is it going to generate a positive value or a negative value? When will VA minus VB be positive? Obviously, when VA is greater than VB, right? And the vice versa happens in the reverse scenario. Now, let's go by with each case. So if I take the charge to be positive, right? So due to a positive charge, what is going to be the direction of electric field? It is going to be away. So this is going to be the electric field if the charge is considered to be positive. And we know an expression that E is equal to minus dV divided by dr. What does this minus sign indicate? The negative sign indicates that the electric field is always in the direction of decreasing potential. So electric field is always in the direction of decreasing potential. So if the charge had been positive, then VA would have been greater than VB, so that VA minus VB would have been positive. So had the source charge been positive, then VA minus VB would have been positive. Had the source charge been negative, then what would have been the direction of electric field? This would have been the direction of electric field, where VB would have been greater than VA, because electric field is directed from higher to lower potential. So when VB is greater than VA, this implies that VA minus VB would have been less than 0. So in this case, answer would have been less than 0. So whenever you have these kind of questions, all that you need to do is use the concept of the relation between electric field and the potential gradient. Never forget the significance of minus sign. What does the minus sign indicate? Electric field is always directed from higher to lower potential. Right? That point should be registered in your mind. Okay, make a note of it. Those who are online, are you able to understand?
Yes, sir.
Yes, sir.
Good. Shall I proceed? The next question is, why is electrostatic potential constant throughout the volume of a conductor and has the same value as inside on its surface also? So if you recollect the concept of electrostatics of conductor, so if you recollect the concept of electrostatics of conductor, the first point that we recollect is the net electric field inside a conductor is 0. So inside a conductor, the electric field is 0. What is the second point? Electric field on the surface of the conductor is always perpendicular to it. So if you take the surface of a conductor, electric field at every point is going to be perpendicular to it. What is the third point? Excess charge that is given to the conductor will always go and sit on the surface, means the interior will not hold the charge at all. So excess charge will sit on the surface of conductor. Am I right? And what is the fourth point? This is the fourth point. So the fourth point is electrostatic potential is constant throughout the volume of the conductor, and it is going to have the same value which is present on the surface of the conductor. So that is the fourth point. And what is the fifth point? Fifth point is electric field on the surface of the conductor takes the value of sigma divided by epsilon naught, right? So it is going to be like this: electric field vector is equal to sigma divided by epsilon naught times n cap, where n cap represents the normal vector which is perpendicular to the surface. So this point and the second point are connected to each other. And what was the last point? It was about electrostatic shielding. Okay, these are the 6 properties of conductors, which is very, very, very important. So why I stressed it here is because among this, one of the properties asked, and they've asked the reason. So if at all any other property is asked, I've already discussed the reasons for each. Okay, you need to remember that. Okay. So here, let's try to prove why this is happening. Again, the same logic. What is it? E is equal to minus dV divided by dr. So let's take the first point. What is the electric field inside the conductor? Because they're saying constant throughout the volume of the conductor, meaning inside. So inside the electric field is going to be 0. So derivative of something is 0 means that something should be a constant. So V should be a constant. And that is the reason why the potential is constant throughout the conductor, but the electric field is 0. Is the point clear? So make a note of this. Here? Shall I proceed? Proof. Same thing. Right. So looking at the next problem, derive the expression for the electric potential at any point along the axial line of an electric dipole. Okay. So this one I've already explained. I'll give you 2 minutes time. Okay. If you remember, directly start deriving it. If not, refer the derivation which I've taught, write it down and show it to me. Check your notes, make it fast. I'm going to check your notes. Electric field due to not electric field, okay? Sorry, electrostatic potential. So all that you need to do is first draw the diagram, take the distances. Never come. அது VA கிடையாது, QA அது. One more minute. Finished, John. Sure. But you didn't write which is R minus A and which is R plus A. Diagram earlier. Diagram there is no R minus A and R plus A. How will I understand? எனக்கு புரியுதுடா கரெக்ட் பண்றவங்களுக்கு எப்படி புரியும்? தப்பு டயக்ராமே தப்பு. இது ஏன்னு எடுத்திருக்கு, இது ஆர்னு எடுத்திருக்கு. ஆர் வந்து it should be a point which is measured from the center. இங்க இருக்கணும். அது ஆறு. அப்ப ஆர் தப்பு. அது இந்த சார்ஜ்ல இருந்து ஆர் மைனஸ். இது ஆர்ரா, இது ஏ போயிடுச்சு. இது ஆர் மைனஸ் தப்பு. that is A. இது டோட்டலா 2A வா? This is A, this is A வா? Then how can this be A and R minus A also? ஒரே distance ரெண்டு வேல்யூ எடுத்து. Center to this point is R. Here to here is R minus A. Logically அதானடா, இது R ரா, இது A. So R ல இருந்து A போயிடுச்சுன்னா this is R minus A. அதே மாதிரி from the what did you take the left charge to be positive? அது leftmost charge. அங்கே the R plus A. Do you all get the answer? So when you take the positive charge here, negative charge here, suppose you are taking, this is the point at which you are expected to calculate the, 1 minute. Okay. See, if you are taking this to be the positive charge, this to be the negative charge, and this is the point at which the potential is expected to be calculated, which is an axial point, you take the center as O and this distance to be R. So first point to be remembered, for a dipole, all the distances of the points is always measured from the center of it. Right? So second, this distance is A, this distance is also A. So how much will this distance be? R minus A, and how much will this distance be? R plus A. So what is the potential due to the charge at A? At point P, what is the value of VA? KQ divided by R plus A. What about VB? It will be, this is where we need to be careful. So when you derive electric field, we don't apply the sign, whereas when you derive potential, you apply the sign, because potential is a scalar quantity. Okay, minus KQ divided by R minus. Clear? So what is going to be the total potential at point P? It is going to be VA plus VB. So what is going to be constant among both? KQ is constant. You will have 1 by R plus A minus of 1 by R minus A. So when you take the LCM and solve, you will get KQ into R minus A minus R minus A divided by r square minus a square. R and r are gone. So what is that you will be left out with? So minus 2a into q. So 2a into q is basically dipole moment. So you will have the answer as minus k times p, the whole divided r square minus a square is approximated to r square. So you will have the answer as minus kp divided by r square. So one important point to be noted here is, since I took the point P closer to the negative charge, my value came out to be minus kp by r square. Had you taken closer to the positive charge, if at all you consider the diagram in the reverse, then the answer would have been plus kp divided by r square. Okay, so this is a point to be noted. Clear? Derive this. But all you don't remember, you can go check the derivation and then do it. I don't have a problem, but do it.
Sir, you are not audible, sir.
Yeah. Now am I clear?
Yes, sir.
Okay. 1 minute. Yeah. So what we did is we considered a uniform electric field in which a dipole is placed in this way. Q is to the right and another Q is to the left for the negative charge. So our job is to derive an expression for the potential energy of dipole moment. It's not movement, it's moment P vector in the electric field E vector. So wherever potential energy is asked, the first thing that we need to calculate is the work done. So if this dipole is rotated through a small angle d theta, then there is a small amount of work dw that is done, which is given by the expression tau d theta, right? So this will be equal to, what is the expression for torque? It is going to be Pe sin theta, right, times d theta, right? If I need the total amount of work done, then I'm going to integrate. So integrate this Pe sin theta d theta from, say, value theta 1 to theta 2. So Pe is a constant. So P into E can be taken out. Integral of sin theta d theta is left out inside from theta 1 to theta 2. So if I take this Pe outside, integral of sin theta is going to be minus cos theta. So it is going to be minus cos theta from theta 1 to theta 2. This will be minus Pe into, substitute the upper limit. It is going to be cos theta 2 minus cos theta 1. So this is going to be the expression for the amount of work done, which will get stored in the form of electrostatic potential energy. But here, what we can do is, if the initial angle was like this, had the dipole been placed perpendicular to the electric field, if theta 1 had been 90 degrees, then if I take this value and plug it here, what am I going to get? I'll get U is equal to minus Pe into cos theta 2. Okay, so what I'm going to do is, if I take theta 1 is 90 and if I take theta 2 is equal to theta itself. Okay, in the place of theta 2, I can substitute theta. So this is basically minus P vector dot E vector. So 2 points to be remembered here is, torque is given as P vector cross E vector, whereas potential energy is given as negative of P vector dot E vector. Clear with this? Right. And secondly, I just want to stress on this: if at all you're doing any derivation without diagram, it will be considered as you have mugged it up. You wouldn't understand the concept. So you'll not get marks for it. Okay, don't do that mistake. Okay. Let's see the next question. There are 2 point charges, 4Q and Q, which are separated by 1 meter in air. At what point on the line joining the charges is the electric field intensity 0? So if I take this to be 4Q and if I take the other charge to be Q, okay, on the line joining the charges, okay, on the line joining the charges, where is the electric field intensity 0? I'll give you 2 minutes time. This problem I solved it yesterday. Do it. I solved a similar kind of a problem. You remember? 4Q and Q. When I discussed the paper yesterday, we had 4Q and Q, but the distance of separation was 2. Check your notes. You would have made a note of it. The answer would have come out as 4 by 3. 4 by 3. So similar kind of a problem. Exact numbers, except that 1 meter, except the 2 meter has become 1 meter. Camera charge. So the question says 2 point charges 4q and q are separated by 1 meter in air. At what point on the line joining the charges is the electric field intensity 0? That is the first part of the question. Second part is also calculate the electrostatic potential energy of the system of charges, taking the value of the charge to be 2 into 10 power minus 7 coulomb. Okay, so let's do the first part of the question. So it is going to be 4q and which are separated by distance of 1 meter, right? So if I take a point P here, then what would have happened? Electric field due to this 4q would have been to the left, and electric field due to q would have also been to the left. So when both the electric fields are in the same direction, there is no possibility for them to get cancelled. So this cannot be possible. Similarly, if I take a point P on the right of both the charges, okay, if I take a point R for instance, on the right of both the charges, electric field due to 4q will be to the right, and electric field due to plus q will also be to the right. So again, in this case, they will not get nullified. They will not get cancelled. So the only option that I'm left out with is I need to take a point P in between the charges, but I don't know where exactly I need to take. So what I'll do is, why is it happening? Because the electric field due to the plus 4q will be to the right, electric field due to the q will be to the left. There is a possibility for them to get cancelled. Right? So if I take this distance to be r, then how much is this distance going to be? It is going to be 1 minus r, because the distance of separation is 1. Right? So at q, the net electric field is supposed to be 0. So what I'll do is electric field due to the 4q charge should be equal to the electric field due to the plus q charge. So what is the electric field due to the 4q charge? It is going to be k into 4q divided by r. This will be equal to, what is the electric field due to the plus q charge? It is going to be k into q divided by 1 minus r. Correction, it is r square 1 minus r the whole square. So this is the electric field, right? So k and k will get cancelled. Q and q are gone, right? So when I cross multiply, I get 4 into 1 minus r the whole square is equal to r square. So this is one way of solving. Or what you can do is, you can do this 1 minus r the whole square divided by r square is equal to 1 divided by 4. Here you have 1, here you have this 4. 4 will go to the denominator. It will become 1 by 4. Taking square root on both the sides, you will get 1 minus r divided by r is equal to plus or minus half. Never forget this plus or minus. Okay. So taking plus, solve it once. Taking minus, solve it once. You will get two different answers. Out of them, one should be eliminated. Let's see what we are supposed to. So when I take plus sign, I get 1 minus r divided by r is half, which implies this is going to be 2 minus 2r is equal to r, which implies r is equal to 2 divided by 3. 2r will go to the other side, it becomes 3r, r will be equal to 2 divided by 3. But where did I take the value of r from? It's 1 meter, so it is going to be 2 by 3 meter. So I took the value of r from the left hand side. So the distance is going to be 2 by 3 meter from 4q. You need to mention that. So 2 by 3 meter from 4q. So when I take minus sign, what am I going to get? When I take minus sign, I'll get 1 minus r divided by r as minus half. So cross multiply, 2 minus 2r is equal to minus r. So 2 will be equal to minus 2r goes to the other side, it becomes plus 2r. So r will be equal to 2. 2 is not possible. What is the meaning of r is equal to 2? It is at a distance of 2 meters from 4q. It is crossing that 1 meter, obviously not possible. So this is rejected. So answer is 2 by 3 meter from 4q or 1 by 3 meter from plus q. Okay. Next is calculate the electrostatic potential energy of the system of charges, taking the value of q as 2 into 10 power minus 7 coulomb. Okay. So what is the formula for potential energy? U is equal to K Q1, Q2 divided by R. So K is 9 into 10 power 9. Q1 and Q2 can be taken as 2 into 10 power minus 7. So another value is also 2 into 10 power minus 7. The whole divided by what is going to be the value of R? Okay. So one is 2 into 10 power minus 7. The other will be 8 into 10 power minus 7 because one is Q and the other is 4Q. The whole divided by the distance of substitution between them is 1. Am I right? So 9 into 2. Or I'll take it like this. So 16 into 9, it's going to be 144 into 10 power 9 into 10 power minus 14. It is going to be 10 power minus 5. So can I write this as 1.44 into 10 power minus 3 joule? Or I can also write it as 1.44 millijoule. Clear? So this is going to be the answer for potential energy. Shall I proceed? Yeah, 1.44. So the next question is 2-point charges 20 into 10 power minus 6 coulomb and minus 4 into 10 power minus 6 coulomb, basically 20 microcoulomb and minus 4 microcoulomb, are separated by a distance of 50 centimeter in air. The first question is find the point on the line joining the charges where the electric potential is 0. Okay. So if I take this to be the positive charge, this to be the negative charge, the positive charge is 20 microcoulomb and the negative charge is 4 microcoulomb. Okay. And whenever we are asked to calculate the point at which the potential is 0, you'll always get 2 points. And those 2 points will be closer to the charge with, sorry? So greater or lesser? Check your notes and tell me. Check your notes. Sure or lesser? Check one. So one is saying greater, one is saying lesser. You are in the previous chapter. I need to check this chapter. Example 2.3. It will be closer to the one with. So I've written it this. Right? So for this kind of a system, the potential will be 0 closer to the charges with lesser magnitude. So which is having lesser magnitude? It is 4. So I need to take a point P here and I need to take a point Q here. Here you will have 2 points, right? So for case 1, what I'm doing is I'll take this distance as R, then this distance will be 50 minus R. So I'm saying that the total potential at point P is equal to 0. When I say the total potential at point P is 0, then the potential due to the charge at A plus the potential due to the charge at B will be 0. So what is the potential due to the charge at A? It is K into 20 divided by this distance is R. So don't forget you have a 10 power minus 6. Okay, you have a 10 power minus 6 is equal to, sorry, plus what is the other charge? K into minus 4 into 10 power minus 6 divided by 50 minus R. So 50 minus R should be equal to 0. right? So answer will be K into 20 divided by R is equal to K into 4 divided by 50 minus R, because 10 power minus 6 gets cancelled. This minus 4 will go to the other side as plus 4. So 4 will cancel 25 times. K and K are gone. Cross multiply. You will get the answer as 250 minus 5R is equal to R, which implies 250 is equal to 6R, or R is equal to 250 divided by 6, or this can also be written as 125 divided by 3 in terms of centimeter. From where? The answer will be 125 by 3 centimeter from the charge A to the right of it. That is point P. So it is going to be 125 by 3 centimeter. Okay. Shall I proceed? Okay. The next part is we need to calculate how far is Q from either of the charges. So we'll draw the diagram again. So if I take this to be 20 and if I take this to be 4, then the point Q is somewhere over here, right? So how much is this distance going to be? If I take this distance to be R, then how much will this distance be? It will be R minus 50, because this is already 50. So using the same logic, potential at Q is 0, which implies VA plus VB is a 0. What is the value of VA? K into 20 divided by the distance is R plus K into minus 4 divided by R minus 50 is equal to 0. I repeat it. I didn't write the 10 power minus 6 because it will get cancelled. Right. So take this value to the other side. So K into 20 by R is equal to K into 4 divided by R minus 50. This and this will get cancelled. So this will cancel this 5 times. 4 will cancel 25 times. So 5R minus 250 is equal to R, which implies 4R is equal to 250. Then what is the value of R? R will be 250 by 4, or 125 divided by 2 centimeter. Right. So it will be 125 by 2 centimeter. This is the second point from the 20 microcoulomb charge at which the potential can be 0. Okay. So I'll solve the next part. Observe. So for this system, they are asking, us to find the electrostatic potential energy. So we know the formula, U is equal to K Q1 Q2 divided by R. So which implies U will be equal to 9 into 10 power 9 into what is the value of Q1? I'm only taking these values, see the magnitudes, 20 into 10 power minus 6 into here it is going to be 4 into 10 power minus 6, the whole divided by the distance of separation between them, which is going to be 50 into 10 power minus 2. Right? 1 0 is gone. Right? So 10 power minus 6 into 10 power minus 6 is 10 power minus 12. So 10 power minus 12, this 10 power minus 2 goes to the numerator, it becomes 10 power 2. So 10 power minus 12 into 10 power 2 is 10 power minus 10. Right? So what you are going to get is 9 into 2, 18 into 4. 72 into 10 power 9 into 10 power minus 10. The whole divided by 5. So 72 divided by 5 is going to give us 14.4. So you'll get the answer as 14.4 into 10 power minus 1 joule. This is going to be the answer. So 14.4 into 10 power minus 1 joule. Done? So the next question is, calculate the work done to dissociate the system of three charges placed on the vertices of triangle as shown here. Okay. So you need to calculate the amount of work done to dissociate the system. So the amount of work that needs to be done to dissociate the system is exactly the same amount of work that we need to put the system together. So when you try to put the system together, what you do is you give energy to the system. What energy do we give? We give potential energy. So whenever you have this kind of a question, all that you need to calculate is the potential energy of the system. Right? We need to calculate the potential energy of the system. So if I take this to be 1, 2, and 3, then the total potential energy of the system will be equal to the potential energy between the charges 1 and 2 plus the potential energy between the charges 2 and 3 plus the potential energy between the charges 3 and 1. Okay. So U will be equal to, if you observe what is U12, U12 is going to be K into Q into 2Q, which is 2Q square divided by this 10. For now, I'll take the distance to be A itself. If you observe the diagram itself, it clearly says it's an equilateral triangle. So K into 2Q square divided by A plus U23 is K into 2Q into minus 4Q. So it is going to be minus 8Q square divided by A plus K into minus 4Q square divided by A. Right, minus 4Q square. So minus 8 minus 4 is minus 12, minus 12 plus 2, minus 10. So minus 10 times KQ square divided by A is going to be the answer. So in this case, it is going to be minus 10 times KQ square divided by A. Had you known the value of charges, and here, of course, you know the distance. Had you known the value of charges, you could have substituted and calculated the final value. Okay? Make a note of it. So we'll wind up with this problem. In the next class, I'll solve some problems based on capacitors. Okay. So you can make a note of it first. You can copy it. You're done? Okay. Then we'll wind up with this. Next class, we'll see the remaining problems. Those are online. Are you clear?
Yes, sir.
Yes, sir.
Did you all copy it? Can I stop the screen share?
Yes, sir.
Yeah.
Okay, sir.
Yeah. You can wind up, guys. You can leave.
Thank you, sir.
Thank you, sir.
Thank you, sir.